Hello and welcome back to Mentally Channel. Today we will guide you through the Dockerizing a Spring Boot application with PostgreSQL. In this video, you will have a fully containerizing application ready for the deployment in your GitHub with CI/CD process. And you will learn setting a Spring Boot project backing, of course, configuring your PostgreSQL in Docker writing a Dockerfile for containerizing the application, and optimizing the image with multi-state viewer. And of course, setting out the Docker controls for integration. And of course, we are going to implement the CI/CD with GitHub Actions. So let's get started. The first step we need to complete here is create our Spring Boot project or generate our Spring Boot project. You can navigate to Spring Initialize and set up for example, maybe Java, the version of Spring Boot, the name of the application, and add the different dependencies you need. But for this, it's more practical. We can easily here in our Intelli IDEA yeah, we have the name of the application, like we can have a name like Dockerizing Spring Boot app. We can put this more short Docker. Yes, Docker Spring Boot. And then we can change this domain, put your domain. In my case, I'm gonna put here mentally. And then you need to choose maybe the version of Java. In this case, we can use Java 17, and then the place where it's located is going to be save your project, and we can use Lombok and Spring DevTools. Of course, we need Spring Web because it's to use to build a web and RESTful application with Spring MVC. And of course, we need Spring Data GPA is to handle the abstraction of the database to make the different consult or queries, Spring Data GPA. And of course, we need Postgres driver, Postgres driver here. Okay, with these dependencies now, Lambda to avoid the boilerplate code, Spring Boot that tool to restart application automatically, and Spring Web for the creation of the RESTful API endpoints, Spring Data GPA to the abstract in connection to the database, and PostgreSQL to the connection to the database of Postgres. And then we can click and create. And for example, we have our application here, and some dependencies is download. So let's wait this complete because we don't know the different dependencies. And then we can search here main Java. And this is the project we generate when we create our um, Spring Boot project normally. And here, for example, we need to define the application property. Sometimes we have a application jar, but in this case, we are going to use a application property for this project. And we need to define these values. For example, this is Spring Data Store UR, is the connection to the database of Postgres, and the username Postgres in this case can be secret or Postgres. Sorry. Well, Let's keep this secret for a while. And here we have the Spring GPA even dialect. And this is to create our database in case, for example, if you could create here, you're going to create database, but if you change in your entity, or entity classes, something is not going to be changed in your database because you have only creator. But if you put here update, you have every change you're doing here in your entity classes, you're going to be applying your database. And here, this is bring JPA show SQL two is to show in your terminal, your command, the different SQL query are implementing when you execute some query in your application or retrieve some data from the database. And we have some create drop. Create drop is meaning like when you run your application for first time, they're going to create a database with the different tables you have in your entity. And then in a case, for example, you implementing, this is not good to implement in production because every time you create a new running your application, you're going to have a new implementation here and you lose your data in your database because it's going to create again. For that reason, I recommend you use this update and keep simple update. And then we can move forward because we need to create an entity here, like a package called sometimes we call entity or model, but it's the same. Okay. And then we need to a Java class for user, and we can define something here interesting like um, the entity here, no, entity, and then we need to define our table with the name of the table we're going to have here, and here users. But of course, we need to define some getters and setters. These annotations are for Lombo and it helps you to avoid the boilerplate code because in case you don't put this, for example, let's show you something here. We need to add identifier here, ID, and for example, we have private, long ID, and the name, private string, or name, and of course, we have the email. For example, if you only have this and you need to generate your get and setter to access these private classes. But if you click here, generate uh, getters and setters, you can generate with these generators or IntelliIDEA, but you have a lot of code now. And imagine you have not only three variables here, not only three parameters, you have 10, 12, or 25 parameters of variables. It's a lot of getters and setters, a lot of boilerplate code. For that reason, we use Lombo to avoid all this boilerplate code. And we use this annotation, getter and setter. This build or the getters and setters by reflection in our application when it's running. And with that, it's okay, perfect. And then we need to have a repository, a user repository here. So we need to create another package called repository. And we need to create an interface here or interface user repository. And here we need to extend our GPA repository, uh, GPA repository, and we need to pass the user, mother, and long. And with that, we are implementing our GPA repository here. And of course, we need to have a user controller. And here we are going to use a user controller. I'm going to create a controller. And here we have a class called controller. And this class is going to implement this, for example. Let's see here. Let's copy it only this part. And we need, for example, we have a user repository, we import, and the mapping, of course, and the user model. User. Perfect. And for example, the main we have here, we need to add some annotation like REST controller and request mapping. And here we put the path of the users. In this REST controller, we have a lot of interview question with this. What is the functionality of REST controller? Why implementing a controller? REST controller. So REST controller is an interface that implementing controller and response body. Controller to handle the different path or methods like get, put, delete, uh, pause, or your different petitions or requests or your endpoints. And response body is to deserialize the object to a JSON. And with that, implementation, we can abstract all this logic here. And request mapping is to have a path or a URL. And with this request mapping, you handle the name of the path or your URL. And that's it. This is the main definition of this request mapping. And here we are injecting our repository. We declare our repository here, and we need to add a constructor here to inject our repository and use in our method on our get map and your method to get our users. And this is a method of a list of user. We have an interface or list, pass the user entity, and then we return, we use a repository, we use this file. It's a method that provide the GPA repository to allow you to find all the user without to handle the script or query creation. This is or handle automatically from a GPA repository. So then we can run our application. And our application is running now. So all is good now. We have some error because, or yeah, I see. Yeah, because our application or database is not running now. For this is the error. But no problem. We're going to run our database in a moment, and we can continue with the configuration of the of the Dockerfile. So we need to add a Dockerfile here, and let's create the Dockerfile. So Dockerfile, yeah. So this Dockerfile, but it's not a Dockerfile like this. We need a Dockerfile. Uh, let's see, Docker compose dot YAML. And with that, we can handle our Docker application here. And we have a Postgres, the image of Postgres 15, the name of the container of this image, and the password we used before. and the port is going to be running in this case, and the bonus, or to say the data of our Postgre. And then we can run Docker Compose up in our terminal. For example, we run this Docker Compose to create the image of the Docker Postgres image, and then we can connect and run our application again. Docker Compose up is running and it's creating the image. It's taking a little bit. You see the Docker is creating the image of the Postgres database, and then you can see it's creating the bottom and it's running now. And then maybe if we running our application now, we can connect to the database. Oh, you see, please. Yeah, I know what is the problem here. Is the name of the database. Okay, no problem with this. We can handle it in a moment. So with that, for example, um, and guys, for example, we have, or let's see, for example, here, or you can compose. And here we have, for example, our image name, the environments or DBA, for example, the UR, compose Postgres, the username, and the password that we are going to use here, of course, and compose Postgres. And then here the name of the database. And then the port of this service is going to be, this image is going to be exposed to, we can hit this with or Postman. And the database image of Postgres and the credentials of Postgres user and Postgres password. Okay, with that information, for example, let's see here. This is it's loading. No, it's not here. Let's see because this is outside because here. If you can see here, we have our controller and we configure our Postman. Sorry, we configure our Docker Compose .yaml, and then we need to run our Docker Compose up. Here to see our Docker Compose up, and our container is running now. So we can hit, and you see we have empty because we don't have any user register on the database already. And then we can continue with our next step that is optimizing the stages of the build process. Because first stage, build the application, and then the second stage, run the application. We can optimize our application with this steps that we propose, and then we can, for example, in our Docker, if you see here your Docker, yeah, we can delete, running again with the optimizing process, and Docker Compose up, and now it's creating already. If you see, we can have it now completely ready, and now it is up. Okay, perfect. We have our endpoint functional recovery. And then our step five is or set up the GitHub Actions CI/CD. So in this process, we need to add, for example, GitHub workflow. For example, this we need to add here in our app, like let's see, like here. Let's see. It's not Java class, it's a file. And we need to create a file here. And then we put that GitHub slash workflow slash CI CD dot ML. And then we have this here, and we can copy these stages. And this is the name or the Spring Boot CICD we are going to use. And then you see you have this meaning when you push to the branch, right? To the branch main, they're going to trigger a job, and this job is going to be with this Ubuntu. The first step is check out the code, and they're going to check out the code inside of the JDK and see if the correct version is 17. And of course, they're going to run this command clean package to package the jar and then create the build Docker image. And then they're going to push the image to Docker Hub. And here you need to have your secret for Docker Hub and your Docker username to login. And with that, we have our implementation of the CI/CD process, but we need to push all these to our repository. And let's go into our repository here, and let's create a repository here. In repository, is going to the name. I'm going to put the name is um, Docker Docker Spring Boot. Yeah, Docker Spring Boot. Docker Spring Boot app. Yeah, and then can create a repository, and we need to initialize this git init and git all. And of course, we need to commit all these um, complete Docker in Spring Boot, Spring Boot app with CI CD, and we the commit and all commits down, and then we can create a branch and push all this code, and we push this all this code we can push, and we have already our code here. And for example, let's see, for example, we have our action here. If you can see, the pipeline is a trigger, and you see if the stage is the build process. And this can have a lot of stages. It's fair because we don't have the credential for all. Yeah, first of all, they don't find the OpenJDK is fine. And of course, in the Docker, we don't have the credentials already set, and we need to proceed with that. The server is stock delivery, copy JDK, found, no, Docker is not found. So with that information, this is going to be our next step to create our CI/CD process, because this is your task at the moment. But if you need all this complete, I'm gonna make another video fixing these errors. But try to sort this, and then we can try to create another video, another second part deploying this completely to the CI/CD process. So thank you so much for watching Mentally Channel. And let's see. And don't forget to subscribe to Mentally Channel. And of course, to Mentally Academy, we have a lot of courses. And we have here different or courses. And we have free courses to all you. And you can sign up in this academy. And thank you so much.